So hello and welcome everyone. Welcome to another video on problem of the day. So can I get a confirmation in the chat box whether I am clearly audible or not? Plus one in the chat box if I am clearly audible. Okay. Hi Rishit. Hi. Okay. And just regarding my audio clarity, is it okay or is it like is my audio clarity okay? Hi Matbar. Hi. Okay. So just let me share my screen. Just a minute. We'll start the session soon enough. We'll wait for a few more seconds and then we'll begin today's session and we'll be discussing the problem of the day. Okay, just let me set up everything. So, can I know how many of you were able to solve yesterday's problem of the day? Plus one in the chat box if you were able to solve the problem of the day. Okay, yesterday was 23rd April and the name of the question was minimum number. So, how many of you were able to solve the question? A quick confirmation in the chat box. Matbar, Rishit. Sorry for like my throat is not. Uh, okay. So the name of the question is minimum number. So first of all, let's read out the problem statement, and then we'll be understanding with the help of an example, and then we'll be discussing the approach on how to solve it. Okay, I see Rishit was able to solve and Matbar also was able to solve. That's really great. And I also think the problem statement as well as the question was not that much difficult and it was interesting and it was easy to solve. That's really great if you were able to solve it. Okay, so let's start. So the question says that you will be given an array of n elements. Okay, and there are some operations which you can apply on the array. So the question says that in one operation you can pick two indices I and j such that array of I is greater than or equal to array of j, that is the other element should be greater than or equal to the next element, to the other element. And what you have to do, replace the value of the larger element, that is array of I, with the difference of both of them. Okay, so over here it is mentioned in terms of indexes I and j. And what you have to do, you have to minimize the values of the array after performing any number of such operations. You can apply the operations any number of times, as much as you can, and then you have to your main target should be to minimize the values of the array. And at the end, what you have to do, after you are sure that you have minimized all the values, you simply have to return the maximum element or the maximum value present inside the array. So that part is mentioned over here at the end, that your task is to you don't have to read anything or print anything. Your task is to complete the function minimum number, which takes an integer n and an array arr. That is the argument will be passed to that minimum number function as input parameters. These are the input parameters, and what you have to do, your function will be returning maximum number which is remaining in that array after minimizing all the values. Okay, so that was what the question says. And now let's take a look at the constraint. So there would be at max 10 to the power 5 length array, and the array element at max can be 10 to the power 9. Okay, so the problem statement is pretty straightforward and easy to understand. I don't think there would be any kind of difficulty, although let's just understand with the help of an example, and let's clear out our understanding. So let me share my other screen. Okay, I hope my screen is visible. So I'll be taking the first test case which is given to us in the question. So that test case is 3, 2 and 4. Okay, so these are the array elements and the size of the array is obviously equal to 3. So now what you have to do, according to the question, you have to select two array elements. Let's say array of I and array of j. And the inequality between the array element is that array of I is greater than or equal to array of j. And now after selecting two different values of the array, what you have to do, you have to find the difference between them. So difference will be array of I minus array of j, and you have to replace the larger value, that is array of I, you have to replace it by the difference of both of them. You have to keep on doing this process until you can't do anymore. Hi, good evening, Matpar. Hi. Okay, so let's understand. So for this array, what we can do, let's say 3, 2, and 4. Okay, so let's target two of the array element. Let's say I'm targeting this two elements. Okay, so selecting 2 and 4, what I'll be doing, I have to, this is my array of I and this is my array of j. I'll be taking the difference of both of them. So that would be 4 minus 2 will give you 2, and I'll be replacing the larger value by the difference. So that would be 2. So the array will look like this. Now again I can apply this process. So I can again select the same elements. So there is no specific process in which the question says that you have to select the two elements in this manner only. You can select randomly any two elements. So again, applying the same process, I'll be selecting the last two elements, 2 and 2, and I'll be taking the difference. So I'll be calling this as I and I'll be calling this as j. Taking the difference, and after taking the difference, I get the difference to be 0. So the ith element will be replaced by 0, and this is what the array looks now. Okay, so now again I will be selecting the first two elements, 3 and 2. So let's take the first two element. This is my array of I and this is my array of j. Taking the difference, 3 minus 2 will give you 1, right? So the larger element will be replaced by the difference. So this would be 1, 2 and 0. Okay, so I again can minimize the values. The first two values can be minimized again. So I'll be selecting the first two elements. So I'll be calling this as array of I and array of j. The larger one will be I. So 2 and 1, the difference will be equal to 2 minus 1 will be 1. Replacing the larger element by the difference. So the array will contain 1, 1 and 0. Again, I can apply the same process on the first two elements. Okay, on 1 comma 1 I can take any of them as my ith element and jth element, because both of them are having the same value, right? So taking the difference, and the difference comes out to be 0. So let's say I'm replacing the first value by the difference, and hence at the end the array looks like this. Now you might be wondering, let's apply the process again and again, but let's apply the process again on these two elements. But if you have any of the other element, if you have any of the element as 0 in the pair, then you can't reduce down the values, right? So let's say if I take the difference of 1 and 0, that would be 1 minus 0 will be 1. You'll be getting the same element again, and if you try to replace it by the same element, there won't be any change observable in the array. So now you cannot minimize any of the values of the array, right? And this is the finalized array in which all the values have been minimized. And now from this array, you have to find out which is the largest value. I can see 1 is the largest value, and this is going to be your output. And you have to print down 1 in the output. Okay. So this is what the question says, and this is how the operations can be applied on any of the array, and this is how you can find out the answer for any of the array. Okay, so can I get a confirmation whether this part was clear to everyone or not? A quick +1 in the chat box if it was clear. Okay, if you have any kind of doubt regarding this question or anything, then just mention it down in the chat box and I'll go through it. Okay, thank you, Rishit. Thank you, Madbar. Okay, so there is one more example, and this example uh, is important for the observation point of view. Okay, now we need to focus on how to solve this question, right? So for that, the example number two, which is given to us with the question, is very, very important. Okay, or the input test case number two. So in the input number two, it is given that the array size is 2 and the array elements are 2 and 4. So I have only two elements. I'll apply the same process on these two elements, 2 and 4. Selecting, I'll be calling the larger element as I and j. Difference will be 4 minus 2 will be 2. Replacing 4 by 2. So the array will look like this, 2 comma 2. Again taking, because I can still minimize the values. So 2 comma 2. Taking the difference will be 0. So I'll be replacing the, let's say both of them are same. So let's replace the larger last one. So the array looks like this. Now, as I mentioned that if any of the element of the pair is equal to 0, then you cannot minimize it again, right? And the size of the array itself is 2. So now you cannot minimize the values further. And this is the finalized array in which all the values are minimized. And the largest value in this finalized array comes out to be 2. And so 2 will be the output for the test case number 2. Okay. So this is how the operations are to be applied on any given array, and this is how we can try to find the answer according to what the question says. Every time take the largest two values and perform subtraction till you get 0. Okay, so you are saying that every time we'll be taking the largest two values and perform subtraction till you get to. Okay. Okay, so now, how we can solve this question? So Rishit says that we can take the largest two values and perform subtraction till you get 0. Okay. But if we observe carefully, see what the question says. You might have already gone through some of the algorithm which you have studied when you started doing mathematics in DSA. Right? If you have gone through mathematics in DSA, then you might have studied many, many different algorithms. Let me give some of the examples. Okay, Aman. Okay, I will join from tomorrow on exact time. Okay, Aman. So there are some of the algorithms, mathematical algorithms that are very important. Let me give some of the example. Sieve of Eratosthenes, Euclidean algorithm, and so on. Okay. So if you observe over here, the question says that you have to select only two elements. If you select only two elements, and after selecting the two elements, what you have to do, you have to replace the larger element by the difference of both of them, and you have to keep on doing that process again and again until you cannot minimize those values. Okay, so that can be clearly observed over here in the example number 2. You can clearly observe that the size of the array was 2, right? Only two elements were present. Now, if I try to apply the operation which was mentioned in the question on this array constantly until and unless I can't apply it anymore, until and unless I can't minimize the values, I will reach down to a phase like this. So the exact base condition will be when all the elements of the array will be 0 except 1. When all the elements of the array will be 0 except 1. That is going to be your end position or the end situation of the array. After that situation, you cannot minimize any of the value. Let me give you one more example. Let's say if you have if the state of the array looks like this. Okay, now you cannot minimize any of the value. You at least need two non-zero values in order to minimize the values, right? If you take one more example, let me give you one more example. You will be able to observe more clearly. Let's say uh, 6 and let's say 5. So over here, let's again and again apply. So I'll not be showing you the process like for 2 and 4. If I keep on subtracting this 4 by 2. So I'll be getting 2 comma 2. Again, I'll be applying the same process on 2 and 2. I'll be getting 2 and 0. So now you can observe you cannot minimize this pair 2 and 0, right? So at the end, you will be having 2 and 0, 6 and 5. Now you can start applying the process on any of the other non-zero elements. Let's say I'm applying on 2 and 6. 2 and 6. So I can do it like this, 2 and 4. Again, that would be 2 and 2. And at the end, 2 and 0, right? So this 2 and 6 have been reduced down to this one. So now again applying on two non-zero values. So that is 2 and 5. So let's apply 2 and 5. That would be 2 and 3. So again applying, that would be 2 and 1. Okay. So now again I can apply on 2 and 1 because over here none of the value is non-zero, right? So I'll be applying and I'll be getting the, I'll be subtracting 2 minus 1 and the difference will be 1. So that would be 1 and 1. Again applying the same process. So I'll be getting 1 comma 0 over here. So 2 and 5 has been reduced down to 1 comma 0. Okay, so I'm showing you this separately. You will be able to observe clearly. Just a minute. The reason why I'm showing you separately for each and every pair possible is that at the end over here you can observe all the elements are 0 and there is only a single element that is non-zero, right? So if you observe over here, in the first step over here I took 2 and 4 and at the end it was reduced down to 2 comma 0. So final value of this, that the non-zero value remaining is equal to 2. In the operation number 2, when I selected 2 and 6, the non-zero value remaining at the end was equal to 2. Okay. In the operation number 3, when I selected 2 and 5, the non-zero value remaining at the end was 1. If you observe carefully, for 2 and 5, the non-zero value remaining at the end after applying all the operation was 1. So this 1 is nothing but it is the GCD of 2 and 5. What is GCD of 2 and 5? It is 1. What is GCD of 2 and 6? So if A is a multiple of B, then we get A and 0 at the end. If A is a multiple of B. Yes, obviously. Like if let's say uh, because you are if you are taking, let's say, a, exactly, yes, what you wrote down is exactly clear, that if the smaller number, if the larger number is multiple of a smaller number, then you will be getting at the end a non-zero value, or you will be getting at the end a GCD, or you will be getting the smallest value of both of them. So over here 2 and 6, at the end the non-zero value remaining at the end is equal to 2. Similarly, over here, for 2 and 4, the non-zero value remaining at the end is equal to 2. For 2 and 4, the GCD of 2 and 4 comes out to be 2. And at the end, over here as well, you can observe the non-zero. This is the Euclidean algorithm in which you subtract the smaller value from the larger value. Okay, this is exactly the Euclidean algorithm. If you have gone through Euclidean algorithm, there are two different types of Euclideans, right? In the one approach is to subtract the one approach is using the subtraction, and the another one is using division. So this is the Euclidean algorithm using subtraction in order to find GCD. So this is the exact Euclidean algorithm. You can directly apply the Euclidean algorithm, and then at the end, whatever is the GCD of entire this one, entire array, is the output. Because at the end you will be applying GCD on the finalized value. GCD of 2 and 4 comes out to be 2. So in the array, this is 2, 6 and 5. Now you will be finding GCD of 2 and 6. You will be finding GCD of GCD and keep on doing that process until only a single non-zero value is remaining in your array. Algorithm send kar dena after the lecture. Which algorithm? Euclidean algorithm. Okay, yeah, I'll be sharing you the code as well, the GFG. I'll be sharing you the link of the GFG ID. Okay, so basically, You simply need to apply the Euclidean algorithm in order to find GCD. You have to simply find out the GCD of the entire array, and whatever is the GCD is your output. Okay, was it clear? Any doubt in this observation? Okay, if you want, if some of you might not be aware about that algorithm, let me just give you an idea. After the lecture, if you weren't aware about the GCD algorithm of Euclidean, so what you can do, assuming A is greater than B, so Euclidean says that if you want to find GCD of A and B, where A is greater than B, so what you will be doing, you will be subtracting the smaller value from larger value and keep on doing this recursively. Okay, and there can be some condition that you can arise at some state in which the other value will be greater than the, let's say if you keep on doing this process recursively, and at some point B is greater than A, then you do the reverse of it. You will be subtracting B minus A, and let keep A as it is. Okay, yeah, 10th में था. Yes, yeah. मतलब why Euclidean algorithm is very important. There is one more approach of Euclidean in which you divide the smaller value. If you divide the larger value by the smaller value, and you keep on doing that until and unless any one of the value becomes 0. And one more observation of Euclidean was that if GCD of A and 0 will be equal to A. Obviously, if you try to find out greatest common divisor between 2 and 0, you know it is going to be equal to 2. Okay, so you simply need to find out the GCD of the entire array. Okay, so let me share the other screen and let's code it down quickly, and let's create an SC, right? Okay, so I'll be applying the Euclidean algorithm using division, okay, to find GCD. So let's quickly code down that approach. If you aren't aware about that algorithm, I highly recommend go through all the algorithms of Euclidean, and also go through the derivation part if you are interested in how the algorithm works. There is a theorem or something like that. You can read it down and you will be getting a better understanding on that algorithm. So first of all, I'll be writing down the GCD algorithm. So you'll be obviously finding the GCD of two integers A and B. So I hope everyone knows GCD, how to find GCD using Euclidean algorithm. So I'm quickly coding it down. After the lecture, I would highly recommend everyone just go through it. So I'm coding down the approach in which you use the division. So in division, let's say for A and B, what I'll be doing, I'll be keeping the value of A. Yeah, okay. Thank you for the confirmation. Okay, so what I'll be doing, I'll be keeping on dividing the value of B. So what I'll be doing, I'll be keeping B as it is, and I'll be dividing A by B. And whatever is the value of this recursion, the recursion will return something, so that value will be returned. And over here I'm dividing the value of B, so at some point B will be reduced down to 0. So if B is equal to 0, that is, if GCD of A comma 0 will be equal to A, so at that point just simply return A. Okay, so this is how you will be getting the GCD. So let's add the return type. So return type, and over here I need to add static, because the other method is also static. So now over here I simply need to find GCD. So let's define a variable. Let's call it as GCD, and let's initialize it as 0, because GCD of a non-zero value with 0 will give you non-zero value as it is. So this is like an identity element for GCD. Okay, so now let's iterate over the array element one by one. And now let's call the GCD function. So I'll be calling the GCD function with the GCD variable and the array element one by one. So this element will return something that would be stored inside my GCD variable. And after finding the GCD of the entire array. I simply need to return it. Okay, so now let's compile and run. Okay, so now let's try to submit and see. So this GCD Euclidean algorithm is very important. You will not get direct implementation of it, just like this one, but some modified questions will be having the uh, implementation of GCD algorithm, right? So just go through that algorithm. Sieve of Eratosthenes is one of the other important algorithm as well. Okay, so those are the most two important algorithm of mathematics for DSA. Any doubt in this? A quick confirmation in the chat box. If you have any kind of doubt, please mention it down. Okay, so now let me share this link as well. Okay, Madbar, I'm sharing you this ID link as well, the code link. Okay, thank you for the confirmation. Just a minute. I've generated the link and just pasting it down in the chat box. Okay, so here is the solution of this, which we just wrote it down right now. I hope you were able to understand and just go through the mathematics part in which Euclide's algorithm and sieve of Eratosthenes. Both of them are very important. And once you face those kind of questions, you will be like remembering me that okay, so once in a session I told you that go through this algorithm and it came out to be very helpful, right? So any doubt, then do mention it down in the chat box right now, or else we'll be ending this session here only. Okay, I'll wait for a few more seconds and then we'll be ending this session. You're welcome, Madbar. Okay, I see no doubts coming, so I think uh, we're good to end the session. Thank you, everyone. Thank you for joining today's session, and best of luck for the upcoming problem of the day. Thank you.